Hello everyone, welcome back to my channel. In this video, we will be covering a wide variety of topics on conditionals, logical, and Boolean operators. The if and else statement is what we will be using throughout this video. Let's first understand a few new operators in Python. Similar to the arithmetic operators we had seen in the earlier part of the series, we have a couple of new operators that we need to cover. The first one is called the floor division operator. Similar to the division operator that is represented by one / symbol on your keyboard, this operator has two / symbols. Let me show it. So for the division operator, we normally use one /, but in the case of this, we use two / symbols. Let me comment that. And the task of this operator is that it divides two numbers and rounds the result to one integer. So let's see with an example. So let's say I wanted to go ahead and divide two numbers. Let's say 104 by 3. The result will be displayed in the form of a floating value number here. Notice, so it says 34.6666. But if I wanted to convert this into an integer, we can pass this expression inside the int function. Now you notice it will go ahead and display the result in the form of an integer. Floor division does exactly the same. It automatically returns the result as an integer. Let me give a space. So let's say I wanted to do floor division. Notice the result now. So you notice without using the int function, the floor division does the task of converting the result into an integer by simply dropping off the fraction part. So this is the only task for the floor division. And now another one is the modulus operator. And this is represented by the percentage symbol on your keyboard. Okay, the purpose of this function is it divides two numbers and returns the remainder. Let's see, let's say 104 divided modulus 7. So the remainder of this expression is 6. Okay, and the modulus operator, you might be wondering what's the purpose, like how is it useful? This is actually very convenient when we want to check the divisibility of one number by another. So let's say we have two numbers x and y, and we wanted to check if x is perfectly divisible by y, then the remainder should go ahead and be 0. What I mean is, so let's say I did let me comment this out. 2 divided by 2. Now this is perfectly divisible by each other, so the remainder should essentially be 0. And notice the result. I'm sorry, I did division there. The result will be 0. Now let's say this x is not perfectly divisible by y, then it will have some kind of a remainder. So let's say 2 divided by 3. It has a remainder here. Let's try other ones like 6 divided by 6 modulus 3. Notice that the result is 0. So this is one of the cases where the modulus operator becomes very, very useful. A Boolean expression is an expression that evaluates to either true or false. So far we have learnt about data types which are either integers, floating point numbers, and strings as well. True and false are special values that belong to the data type called bool. Let's check them out with some certain examples. Let's say I did print. Okay, and when I go ahead and run this, you notice the result is true on screen. Okay, so this basically compares operands and produces true if they're equal and false otherwise. So let's say I do 5 is equal to 3. You will notice that the result is false because these two operands are not equal. Alright. Now you might wonder, why are we using two equal signs? This is actually one of the many relational operators in Python. The difference between using one equal sign and two equal signs are very simple. Using one equal signs is interpreted by Python as an assignment statement for a variable. So let's say I had a variable called var and I use one equal sign. Let's say I put a value like 5. This is an assignment statement. I'm trying to assign the value of 5 to the variable named var in this case. Okay, but when I'm using two equal signs, Python is going to interpret it as using the equal to relational operator, which I'll show you. Okay, so in this case, just like we had seen, it's 5 equal to 5 equal, and the result is true. We can also do this with strings. So let's say I want to compare two strings. So let's say it's hello. The result here would be true. And suppose I did some minor change, even in the case of making one of the edge uppercase, it will go ahead and throw me the result as false because they are not equal. So this is the equal to operator. So these are some of the other relational operators as well. So we have the not equal to, greater than, less than, greater than or equal to, or less than and equal to as well. You might remember all this during your high school mathematics. We might have used most of these operators, but of course, the way we represent them is kind of different in Python. So let's try to understand how to use the not equal to operator. So we do print, let's say we do 100 is not equal to 99. So using an exclamation mark and the equal sign represents the not equal to operator. So when I run this, the result should be true because 100 is essentially not equal to 99. But let's say, in a sense, if I put 100 is not equal to 100, then the result will be false here because the expression is evaluated to check whether the two operands are not equal. But in this case, they're actually equal. So that's why the result will be false. So we can try another one like print 100 is less than 99. Think about it. The result will be false because 100 is basically greater than 99. Same way it goes for the greater one as well. So let's say I change this to 100 being greater than 99. It's going to be true. And we have other ones like greater than or equal to. So 100 is basically greater than or equal to 99. It checks those conditions. So it is true and it's going to return that. So let's say I do 100 is less than or equal to 99. This is of course going to be false. So 100 is in no way less than or equal to 99. Now let's try and use a much more complicated expression. So let's say we do something like 100 divided by 50 is not equal to 4 divided by 2. Okay, so in this expression we are dividing 100 by 50, so the result to that is 2, and we're also doing 4 divided by 2, which is also 2. But what the expression is trying to say is the values of these two individual expressions, that is the operands, is not equal, but in essence they are actually equal. So you will notice that the result will be false here. Okay, so it's simply, let me break it down to you. So it's going to be print 100 by 50 is 2, and we're saying is not equal to 4 divided by 2 is again 2. So the result to this is going to be false. Let me comment this out, print this. You notice the result is false. So this is one way of how we can also do it. So when I'm talking about relational operators, it's not just about using individual elements. We can use entire expressions and compare them with other expressions as well. So let's try another one. 100, let's use the same example, and by 50 is equal to, in this case, 4 divided by 2. You will notice that the result here is going to be true. Now that we have understood about relational operators, let's learn about logical operators. Python has three logical operators, that is, the AND, OR, and NOT operators. The meanings of these operators are similar to their meanings in English. For example, look at this image of the Venn diagram that I took out from the internet. It clearly explains the semantics of these operators. Look at the first one, the AND operator. It is a puppy and a kitten. So we are including both the terms, puppy and kitten. Look at the second one, the OR operator. We are referring to either a puppy or a kitten. Okay. And finally, look at the NOT operator. We are referring to just one term. In this case, it's a puppy, not a kitten. Okay, that's the most simplest explanation of what these logical operators do. Now let's explore these logical operators with examples in Python. So let's try the AND operator. So let's try something like print 10 is greater than 5 and 3 is greater than 2. Okay, so in this example, the interpreter evaluates both the expressions. And since 10 is greater than 5, which is true, and 3 is also greater than 2, that is also true, the overall result will be true. Okay, so you see the result is true. Even if one of these expressions is false, either 10 is not greater than 5, if I did something like, say, 3 is lesser than 2, since that is false, even if one of these expressions is false, the overall result will be returned as false. So that's what the AND operator does. Now let's try one with the OR operator. Let's just take the same one. Okay. Let me comment this out. So in this case, think about it for a second. The OR operator will include either one. So it will check the condition for either one of this and return the result. Now notice in this case, the result will be true. Although the second expression is still false, 3 is not lesser than 2. This is because the OR operator is true if either one of both the expressions is true. So if let's say 10 is greater than 5 is true, and if 3 is also greater than 2, it will return true. Or if let's say one of these conditions is true, is also completely fine for the OR operator. So in this case, the second one is false, but still it returns true because the first condition is satisfying it. So this is how the OR operator functions. But let's say both the conditions are false. In this case, then the result will be false. So it's either one of these expressions is what the OR operator will go ahead and check. Now let's try the NOT operator. So the NOT operator, it goes ahead and negates a Boolean expression. This might be a little confusing, so focus here for a minute. Let me give you an example. Not 3, 2. Okay. So in this case, although the expression is true, but placing the not keyword in front of the expression will return false. So in general, this is an expression that might give us a result true. But if I put the not operator in front of it, it will automatically go ahead and return the result as false, and vice versa. So let's say I put a false expression in front of this and put the not operator in front of it, it will return the expression to be true. Again, don't try too hard to remember this. As you keep practicing it, you will get a hang about it. Conditional statements give us the ability to check conditions and alter or change the behavior of programs. A simplest example is the if and else statement. Let's explore them with one example. Let's say we have a variable called x and it has the value of, let's say, 15. Okay. Now let's create a condition on this. If x is greater than 0, okay, print x is positive. So what this condition did is, I have gone ahead and stated that if the variable x is positive, then run the intended statement, which in this case is to print a string saying x is positive. And look at the result. It evaluates the Boolean expression, okay? X is definitely greater than 0, hence it prints the result as positive. Now what happens if I change the value of the variable to be less than 0? Let's say I put a negative number. Let's make this minus 15. And let's see how this conditional statement behaves. Notice that once I change the value of variable x as minus 15, the value is lesser than 0. Hence, the conditional execution doesn't return any output, because the condition was to return an output only if the value of x was greater than 0. Also, if statements have the same structure as a function definition. So like we had seen in the earlier series of function, it has a header followed by an indented body. Statements like print statements can also be called, and we can write multiple statements. There's no limit in the number of statements that can appear in the body, but there has to be at least one statement minimum, like the one which we just did in our case. Now let's try to use an alternative example. So let's say we have x is 100, and let's try to do an alternate execution here. So let's also include the else statement as well. So I'm saying if x divided by 2 is greater than 10, okay, print x is greater than 10, else print x is not greater than 10. So in this example, first of all, when I'm talking about alternate execution, this is a scenario where there are two possibilities and the condition determines which one runs. So what we've done is we've created a variable x with a value of 100 in it, and the condition states that if the value of x is divided by 2 and the resulting value, in this case it should be 50. If 50 is greater than 10, then go ahead and print that x is greater than 10. If the resulting value, if x divided by 2, if the value is lesser than 10, then print the alternative condition, which is print x is not greater than 10. And in this case, it is definitely condition number 1. So it is going to print x is greater than 10. So let's try to reduce this value. Let's do it to 15. And 15 divided by 2 is 7.5. 7.5 is a value that is lesser than 10. Hence, the resulting value here will be x is not greater than 10. This is called creating alternative branches. So when we go ahead and give different conditions, it's called creating branches. This is basically creating branches in the flow of execution. In most programming cases, there are more than just two possibilities while determining the flow of execution. So this is just a requirement for more than just two branches. Example, when we have to express computations which contains more than just the if and else statement, just two conditions, that is when we have a requirement for chained conditionals. Let me show you with an example. So let's say we have x is equal to 16. If x is lesser than 10, print x is less than 10. elif, I'll explain what the elif is. So notice in this case, the answer is essentially x is greater than 10, but what happens here is the elif keyword So that is just simply an abbreviation for else if. So that's stating that apart from just x is being greater than 10 or x and 10 are equal, if there's an other condition which I'm introducing here, if x is also greater than 10, okay, and we can have as many number of elif statements. There is no limit of that. Okay, if there's any clause of having an else statement, like in this case, it should always come in the end. Else statements cannot come before elif statements. It will always come in the end itself. So in this example, we stated that if the value of x is less than 10, then execute the first statement. If the value of x is greater than 10, then execute the second statement. And in all other cases, execute the third statement. And the only case pretty much where the third statement would be executed if the value of x and 10 is equal. So let's say I change the value of x to be 10, then the else statement would be executed here. X and 10 are equal. So this is what we call a chain conditionals, and I can include as many elif statements in this program as I want to, but I've just chosen to include one for the example. The else condition is not always compulsory. We can just create a chain conditional by using only the if and elif statements only. So let's say we had x is equal to 10, y is equal to 20. If x is less than y, print x is less than y. Sorry, elif x is greater than y, print and I can, instead of just going ahead, let's say I want to use another statement, instead of using the else, I can use another elif. It's the same example, but I've just done it without the use of else statements, and this is also legal. Okay, I'm sorry, I did x elif x is equal to y. Yeah, so in this case, of course, x is less than y, but let's say if I did x is 30, x is greater than y, and if I make the values same, you notice it says x and 10 are equal. So there's no requirement or a compulsion for you to go ahead and use else statements, but if you are going to use the else clause, make sure that it comes in the end, always in the end. It can never come in between. As the name suggests, nested conditionals comprise of conditional statements contained within the definition of an other conditional statements. So let me show you with an example. Let's say I have an example of x is equal to 5. If x is less than 10, print x is less than 10. If now this is what we call a nested conditional. If x is greater than 5, print else. Okay, my bad. Okay, so in this example, we have done three conditions. That is, the outer condition, the first one, checks if x is less than 10. If so, then the nested conditional, which comes after that, will again check if x is greater than 5 or less than 5. So the conditional will not return anything if the value of x is greater than, if the original value is greater than 10. If let's say it's 11, 12 or 10.1, 10.5, it will not return anything. But the minute it recognizes that the value of x is lesser than 10, then it will go to the next nested conditional within that, which checks if this value is greater than 5 or less than 5. And it will return the required output as such. So in this case, the value is pretty much equal to 5 itself. Okay, so the first condition, it prints x is less than 10, and after that being true, it will check the next one saying x is less than 5. So if x is equal to 5, it will just pretty much come in the second category. So let's say I did x is 9, for example. So you see it says x is less than 10, x is greater than 5. Now what if I make the value of x more than 10? Now you notice it will not return any result, because the outer condition will only start executing or start returning values if the value of x is less than 10. So this is the concept of nested conditionals.
That's the end of part 4 of the series. Stay tuned for my next video. We will learn about looping and iteration, a concept very useful when we want to run a block of statements repeatedly.
If you like this video, please like, share and subscribe to my channel. Have a good day.